Hi everybody, welcome to Algebra 1 class. I'm Batman.
Well, I'm not Batman.
But at least we have Batman in the class.
Alright, what's going on, folks? I'm going to start up another recording just kind of as a backup recording to this first recording, and hopefully this all works out fine. Let's get this thing started, but 1 second, let me just kind of make sure I've got my backup recording going, and then we will get this.
Hi you guys, how are you doing? I'm Batman.
Okay, 1 second. Yeah, we've got two people who claim to be Batman. It's a little pathetic, really, if you think about it. I mean, not to say that you're pathetic, but I'm just saying. We are that big of nerds, I think. Let me close the door. Alright, folks. I think I've got everything set up. Let's get this party started. Get this show on the road. Ugh, there we go. Hey, what's going on, dudes? How's it going with you? Can you hear me? Can you hear me all right? Can you hear the words that are coming out of my mouth? Try to get inside of this pocket right here. I feel like, I don't know if you guys figure this out. A lot of people say, hey, why is he writing on top of his webcam? I'm not writing on top of his webcam. There's a big piece of glass in front of me. I'm writing on top of a piece of glass, and right now there's a fly inside my office. I hate that fly. Anyway, let's get this thing started. We don't have a whole lot of time, so let's just go through this. I think that I'm going to skip a few of these because we covered these things. We covered this. And did you need anything? Okay. And let's see, equation for, yeah, we did cover this one. We covered this stuff over here. We talked about this stuff. Okay, wait, let me take a look at this one. Okay, right, here we go. Or these exponentials. Okay. I felt like the last thing I covered with you guys was the rules of exponents, but anyway, I think that I'm here, and then after that, I think that I'm on the next one. So I'm going to try to upload. I'm going to try to download and upload things, and we'll get through this as quickly as possible. Sound good? All right, we're doing warm-up 2. Can you guys look on the computer screen and see what we got? Functions f and g are represented by the graph below. Which one is with the graph or with an equation? Wait. Okay. Oh, I see. I get it. All right, anyway. They gave you 3 functions. One of them, they gave you a graph. That's a graph. This one, they gave you an equation. This one, they gave you an equation as well. All we need to do to evaluate it is pretty simple. It's pretty straightforward. All you got to do is this. They want to figure out, well, what is f of -3? That's what they want to figure out. Well, all you do is you figure out, well, if you plug in x equals -3, because usually we look at it as f of x, right? And remember, that doesn't mean f times x. What that means is f of x, right? The variable in our case is the x letter. So when we want to figure out what f of -3 is, that's saying evaluate the function such that x is -3. So if I plug in -3 into my f of x, I can see it. And actually, instead of giving me an equation, they gave me a graph. Well, that's pretty simple too, because all we got to do is look on the graph. It's really hard to see. Let me zoom into that spot right there. It looks to me that like at x equals 3, so it goes 1, 2, 3. What is my y value? Look at it right here. I've got my mouse right over it. What is the y value? How high is this line at x equals 3? Come on, you guys, talk it out to me. Talk it out. It makes this process a whole lot easier. You would say 1. I would say it looks to me like it's 0. Because if you look at the graph and you zoom in really well, at 1, 2, 3, this thing is at height 0. Does that make sense? Now, if you want to say that y equals 1, I would say that you have to go all the way out to where x equals 5. Because then, in that case, x equals 5. Then you'll have y equal to 1. I agree with that. But I would say at x equals 3, you have x equal to 0. Actually, I screwed up. Right? Do you guys see what I did? Was I looked at what is f of 3, but what I should have looked at is what is f of negative 3. All right, fine. Tell me what that answer is. How high are you when you're standing out at x equals negative 3, but you're standing on this line? I guess a more appropriate question would be, how low are you? Negative 4? Let me see. If I go out 1, 2, 3, I would have to go 1, 2, 3 down. Negative 3. I would say close, Laura, but it's negative 3. Because it goes backwards 3, and then you look over here, it goes 3 down. So, my answer to this problem right here is just negative 3. And the graph is easy to deal with. Are we cool with that? Alright. So let's try this as warm-up. By the way, they said that they want us to figure out what g of negative 2 is. And what did they say g of x is? By the way, I'm going to erase this, if that's all right with you. G of x is equal to 3 times 5x. But what they want to figure out is what is g of negative 2. So all I got to do in that case is I compare this equation to this equation. And apparently they want me to replace anywhere I see an x with a negative 2. I can do that. That's 3 times 5 to the negative 2. Now, I can't remember, but I'm pretty sure, didn't I teach you guys the laws of exponents before? I know I did. I'm sure that I did because I taught you guys last year in algebra. Well, I guess I taught that. I didn't teach you guys math. I taught you science, but I feel like I did. Do you guys know what the negative 2 does? If you don't know, say IDK. It goes back into a decimal. I don't remember. I almost want to go back and make sure that I did teach this to you. Huh. I guess it doesn't, I don't, gosh, I'm almost sure that I remember teaching this to you. Anyway, why don't I just show it to you now? I'll tell you what the answer is, and then I'll tell you what's going on. Okay? When we have this, now take a look at this negative 2 out here. Whenever we have negative exponents, it makes the thing that it's acting on. Now, first of all, what is this negative 2 acting on? Is it acting on the 3? Is it acting on the 5? Or is it acting on both? It's acting on the 5 specifically, right? Now, here's another question. Is the 5 in the numerator or the denominator? Say numerator, denominator, or I don't know. Alright, Justice is saying numerator, and Laura's saying IDK. And I kind of feel like I know what Justice is saying, and also Laura is saying, and some of you guys are saying denominator. Alright, the answer is it's in the numerator. Because the number 5, because you guys are thinking, wait a second, that doesn't make any sense. He just gave us the number 5, and he asked us, is that in the numerator or the denominator? But don't you need a fraction in order to deal with numerators and denominators? Does that make sense to you? Don't we need a fraction?
There's a truck over there, too. Where? Inside the other house.
Kaylin? If it's alright with you, I'm gonna mute you. Alright, sorry. Yeah, don't worry about it. I'm sorry. Alright. But what I'm saying here is, he just told me the number 5. Don't you need a fraction if you want to talk to me about the numerator and the denominator? And I say, well, technically, yes, but technically you can kind of think of this as 5 over 1. Because that's the same as the number 5. So if that were the case, then this is definitely in the numerator. I kind of see where you guys are coming from, because you kind of thought, well, maybe this is the numerator, and so this 5 is on the bottom, so therefore it's in the denominator. No, I'm talking about the number 5. Is that in the numerator or the denominator? Technically, it's in the numerator. Alright? Are we cool with that so far? Okay? So really what I'm going to write down is, I'm just going to write this down, because you guys don't really, so let me get this straight. You don't know how to deal with negative exponents. Sup, Corey? Come on in real quick. Alright, so you're Algebra 2.
Yes, sir.
Right? You are hanging out. I've got Algebra 1, I've got physics class, but at 2 o'clock I'm going to work with you.
Awesome.
Stuff.
I have 3 packets for you right here.
Awesome.
I was getting stuck up on the reviews last night. Sorry, not meaning to take your time. Just want to let you know.
It's alright. Don't worry about it. Alright, cool. I'll see you later then.
You want me to just set these down right here?
I'd rather you scan them and turn them in,
awesome.
because I can't grade it if it's by paper.
Okay.
Alright.
Awesome.
And I can help you. Just picture.
Okay.
Awesome. Okay. What you do is, alright, let me read what you guys are saying. Does that mean you take the exponent? Does that mean you take the decimal on the left? No. Okay. You move the exponent to the bottom. Actually, Jillian, that's exactly what you do. What this negative exponent does, is it takes this thing right here and flips it upside down. So this becomes 3 times 1 over 5 squared. So I changed it from a negative 2 to a positive 2 by what we call inverting it. Okay? Now what you need to do now is you need to square the top and square the bottom at the same time. So 1 squared, so I'm just going to do that just to kind of make it a little bit easier for me. So I have 3 times, what is 1 squared? What is 1 times 1? It's just 1, so it doesn't really matter. Divided by 5 squared, which is 25. Or g of negative 2. So that's my answer. G of negative 2 is 3 over 25. By the way, 3 times 1 is the same as 3, so we just kind of get rid of that thing right there. So the numerator is 3, the denominator is 25. Does that make sense to you? You guys get it? Which is actually exactly what the answer they got. Awesome. All right, let's try this one, okay? Here's another property. Oh, I'm sorry. Can I erase this? All right, take a picture. Pop, pop. 3, 2, 1, erase. Got it. All right. Here's another concept that is very important for you guys to know. What is g of 0? Okay, well, let's plug in 0 into this. So we have 3 times 5 to the 0th power. Do you know what 5 to the 0th power is? It means 0? No, it actually doesn't. And this is kind of a funky thing. Jillian's right. The answer is 1, actually. Anything to the 0 is 1. even 0 to the 0th power is the number 1. That's just something you have to know. 0 to the 0th power is equal to 1. I know, it's crazy. But anything to the 0th power is equal to 1. Alright, fine. So, that means this right here is g of 0 is equal to 3 times 1. Which is pretty easy, and it's just 3. G of 0 is equal to 3. Does that make sense to you? Are we cool with that? Awesome. Can I erase this? Maybe I went over exponent rules with my Algebra 2 class. But I was pretty sure it was you guys. Alright. Alright, let's do this one, ready? Let's do number 3. I'm going to erase. 1, 2, 3. Okay. For number 3, let's take a look at it. They want us to figure out what h of negative 2 is. If I want to figure out what h of negative 2 is, I got to know what h of x is. So look right above there, right up here, it says h of x is equal to negative 3x squared plus 7x minus 1. Okay, so all I'm doing here is I'm just going to take this negative 2 and I'm going to plug in where I have an x. I'm going to replace it with the number negative 2. Be careful with writing this. This is negative 3 parentheses negative 2 squared plus 7 parentheses negative 2 minus 1. Now why would I go through all of the pain of making parentheses, parentheses, and parentheses? It's just because I want to be very careful with what I do with this negative 2. Now what do I do first? Do I do the multiplication? Do I do the exponent, right? Because remember, PEMDAS. Please excuse my crazy Aunt Sally. So inside the parentheses, there's nothing to do. So next thing I'm going to do is the exponents. The only exponent I see is this 2 up here. All right, since it's not a negative, I don't have to worry about flipping, inverting it or whatever. And since it's not 0, I know that that's not going to be 1. So I just square this. What is negative 2 times negative 2? Positive 4. There we go. So all I'm going to do is negative 3 times positive 4 plus 7 times negative 2 minus 1. Now I can just multiply everything out. By the way, Colette, you understand why it's positive 4? Good. Awesome. So now I multiply these together. I've got negative 3 times 4, which is negative 12. I've got 7 times negative 2, which is negative 14, minus 1. Let's see, that's 15, 25, 27. So that would be negative 27. We cool? Alright, do you guys think you guys can do the rest on your own? Alright, let me start off with number 7. We'll see what that looks like. Alright. I'm going to erase this. Okay? By the way, I'm finishing at 11:10, just to let you know. Alright. Functions. F and g are both linear functions. Let me see something real quick. Okay, just taking a look. Functions f and g are both linear functions. Got it. All right. F of 0 and g of 0 equals the number 2. Okay. F of 3 equals 2 g of 3. Got it. What are we supposed to do? Verify that the equation for the function. Oh, I see. They told us what f of x is. F of x is equal to 2x plus 2. They told us what f of x is. I bet you they're going to ask us what g of x is. All right, anyway. f of x is equal to this equation right here. And they told us, they made this audacious claim that f of 0 is equal to 2. Let's check that. Sound all right? All you do is you plug in 0 in for x. 2 times 0 is 0, plus 2, well, that's 2. Good. I concur. I agree that f of 0 is equal to 2. Do you agree? Okay. What is f of 3? Well, they're asking for f of 3. So all I think I'm going to do is take that 3 and plug it in for x. If I put the 3 in for x, I end up getting 3 times 2, which is 6, plus 2, which is 8. You guys see how I got that? All right. Then it says, what is g of 3? Well, what you do is you take a look at the equation they gave you. They say f of 3 is, well, we know what f of 3 is. It's 8. And apparently 2 times whatever this number is equal to 8. So what is this number, which is g of 3? Come on, you guys, answer the question. I'm waiting for you guys. Come on, hurry up. Oh, come on. Am I distracting you guys? Come on, answer the question. They told you that f of 3 times 2, or f of 3, here they gave you this. F of 3 is equal to 2 times g of 3. This is a number. This is a number. Number, number. We know what that number is. It's that. It's 8. So if 8 equals 2 times some number, what is that second number? That's 16. Think of the opposite, kind of go the opposite way of the direction you're going. It's 4, exactly. G of 3 is 4. You guys get it? All right, now here's my question to you. Oh, by the way, we know what g of 0 is. What is g of 0? There we go, it's 2. Exactly. How did you know that? Well, you look up here and it says f of 0 is the same as g of 0, which is 2. Right? Both f of 0 is 2, g of 0 is 2. Do we have enough information here to graph this thing? Well, I would say, and I know I went over this with you, how many points do I need in order to graph something? I need 2 points. Now I have 2 points. Like, let's take a look at f of 0. I know what f of 0 is. It's 2. So at x equals 0, y will equal to 2. So that's one of the points that's on that graph. Another point is that x equals 3, y is equal to 8. So something way up here. This is f of x. What about g of x? So this is f of x. That's the graph of what this is. What about g of x? Well, I know that g of 0 is 2. So it crosses at the same point. But at g of 3, I'm only going to go up to 4. So it's 1, 2, 3, 4. This, my friends, is g of x. Aha! Does that make sense? Okay, awesome. All right, let's try this one. 10. Now this right here, we begin by looking at the connection between symbolic representation of a function and graph by focusing on the linear functions. All right. In middle school, you studied properties of the y equals mx plus b. You're familiar with this category of functions and may have worked with them previously. All right, let's see. For this exercise, you will be given 10 equations that represent 10 functions. You will be given a packet. Did Mr. Daldy give you that packet? Oh, I did. Fine. All right. Let's figure out what we need to do with it. I give you 10 equations that represent 10 functions. You should be able to, or you will also be given a packet of graphical representations of 6 functions. Each of the graphs correspond to one of the given equations. A, find the equation that matches the graph. B, justify the match by showing your equation works with at least 2 points. C, answer the follow-up question. D, add the answer to the follow-up question to the graph and the location of the point should be reasonable. All right. All right, so let's see. What do they want us to do? Let's see. Oh, okay. All right, got it. So, let me zoom into this. Check this out. They gave us a graph. Okay? They gave us a graph, and I'm going to actually show you a few tricks here. They gave us a graph, and it looks something like this. And they even gave us a bunch of points that are on that graph. Can I ask you this? What do you think the let's see, what would the best be? What do you think the slope of this graph would be? Is it, all right, here's my question. Do you think the slope of this graph will be positive or negative? That's my third question. Take a look at this graph right here. Actually, you know what? Here's what we'll do. I'm going to do one that doesn't actually have an answer. Let's take a look at this one. Let's look at this graph. Because this is actually your homework. All right, fine. Mr. Daldy is doing my homework for me. Cool. All right. Here's how I would graph this. Let's look at this graph right here. -2, 0. That's one of the points. The other point, it's not the y-intercept. It's actually up here, which is 1, 6. Okay? Is the slope positive or negative? That's my first question. Because what I really want to do is figure out what the y equals mx plus b is. So if I could figure out what the m is, then I can figure out, and I can figure out what the b is, I'd be happy. All right. It's positive. Yeah, it is positive because it's going up. This graph is going up, so therefore it's a positive slope. I agree with you. Okay? Now let's figure out what it is. What is the slope? Now remember I told you that there's a bunch of equations I could have you memorize, but instead I'd rather you really understand what it is. What does m represent? It represents 2 words in a fraction. It's something over something. It's the rise over the run. Exactly. Very good. It is the rise over the run. So here's my question. How far, if I'm going to start at point 1 and I'm going to go to point 2, how far did I have to rise? If I'm going from this point over here to this point over here, how far up did I have to go? This is my easy way of figuring out what the slope is. 6. Because you started down here at y equals 0, because when we're talking about the height, when we're talking about going up and down, we're only focusing on the second number, because the first number is the x, right? So the second number is 0, and you're going all the way up to 6. So obviously, Justice, I totally agree with you. Does everyone understand how Justice got 6? Alright, now we got to worry about the run. How far across did I have to go to get from this point to this point? I'm only talking about horizontal distance here. Horizontally, how far did I have to walk to get from here to there? Three. I got the 2. I got a 3. Alright, is it 3 or 2? What's your thoughts? Alright, I agree it's 3. Because, and I see where your idea is too, is this thing's standing out here at -2, this thing's standing out here at +1. In order to get from here to there, I need to go 1, 2, 3 across. So my slope for this is actually 6/3, which is known as the number 2. Did that just make sense to you? Alright, now I'm going to show you the cheater's way of doing the y-intercept. Because I could show you this crazy formula called the slope-intercept form, or the, I think it's the, not the slope-intercept, but the point-slope formula, and that kind of stuff. But let's just do it this way. I guess the way I'm thinking about it is, this tells me that since my slope is 2, that tells me that for every 1 I go across, I actually have to go up 2 slots. Right? Because I go 1 across, up 2. That's the slope. So I start here, I go 1 across, up 2. Got it? I'm going to do that one more time. I'm going to go 1 across, up 2. What is this point right here? What's the coordinates of this point right here? Justice is saying 5, 0, 0, 5. Well, okay, Justice, I agree that it's a 0, something. I don't think it's 0, 5. I think it is actually, Bailey's got it right. It's 0, 4. Because what you did was you went across 1, up 2, and how high are you at this point? If you started over here at 0, you went across 1, up 2, you're standing at 2. You went across 1 again, and you go up 2 again, that's 0, 4. My y-intercept is 4. I can tell you the equation of this line right off the bat. It is y equals 2x plus 4. Should I prove that to you? Sure, I'll prove it to you. If I plug in, this isn't y, but it's actually f of x. It's the same thing. I should just put y equals f of x equals blah, blah, blah. But if I plug in -2 into here, f of -2. If I plug in -2 in for the x, I'll have -2 times +2, which would be -4, plus 4, which will give me 0. Is that a good thing? F of -2 is equal to 0? I say it is, but why? Why is that a good thing? Well, it's a good thing because, remember, one of the coordinates of my points was -2, 0. And it says if x is equal to -2, that's what I have written here, then f of x should equal 0. That's what I have there. See, I can test these equations out by plugging in points. I can choose that point over there. If I plug in x equals 1, I hope that I'll get f of x equals 6. Does that agree? Well, 2 times 1 is 2, plus 4 is 6. F1 comma 6 is one of the points on my graph. Does that make sense to you? Now, I'll admit to you, and I'm realizing this, the graphs that they gave you aren't always straight lines. They're crazy little, they're crazy looking graphs, but what you will need to do is plug in x and the y coordinates for these things. Alright? This is a good exercise. I want you to be able to do this. But anyway, class is over. I got to get finished so I can wrap up and start teaching the next thing. I'll talk to you guys later. Goodbye. Oh, one more thing. On Friday, grade checks are due, so I need you guys to turn in your stuff because I pretty much went through and graded everything. Alright, so check, and if I miss something, you're going to need to tell me.